Hello and welcome. I'm Praveer, and today I'm going to provide a brief overview of the quaternary interpretation of quantum dynamics, that's QIQD. This is in preparation for a keynote that I'll be delivering in 3 weeks rather, at the ICTIS 10th Annual Conference to be held at the Cornell University campus in New York City. Now, I'm going to begin with the idea of nature as a single system, and then suggest a mechanism of reverse extrapolation that can be used to read the quantum level. This will give way to the idea of a fourfold quantum object code that I propose accompanies any quantum object. I'll talk about quaternary dynamics across scale and then highlight QIQD. And QIQD, of course, is quaternary interpretation of quantum dynamics. I'm going to compare QIQD to other quantum mechanical frameworks briefly. And then I'll also compare the qubit that arises when one considers QIQD with some of the other qubits on the market. I'll step back and just look at the research and journey that I've gone through, and then suggest a future vision for QIQD and the technology that arises from it. So it's evident that all nature is a single system. We know this because all quantum particles are sourced from quantum levels. All atoms are sourced from quantum particles. All molecules are sourced from atoms. All molecular plans, and that's the basis of any living cell, are sourced from molecules. So it's evident that there's a tight integration between one layer of nature and the next. So the question is, what if we study it as a single system when trying to get insight into one layer, any one layer? And here, of course, our interest in the quantum layer. And the hypothesis is that, of course, we've developed frameworks like the Copenhagen interpretation and so on that look solely at the quantum level. But the proposition here in the quaternary interpretation of quantum dynamics is that we should look at patterns that occur across these different levels that clearly are tightly integrated to get further insight into the quantum level itself. So this leads to this idea of reverse extrapolation. So I want to start from larger levels that we've done a lot of research, and there's a lot of concrete science that accompanies this, and look at any living cell. And when we look at a cell, then we know that there's 4 molecular plans that animate it. These are called proteins, polysaccharides, nucleic acids, and lipids. And when we try to denominate the functionality, the core functionality of these molecular plans, I can make the case that, for example, polysaccharides that are chains of sugar molecules provide power to the cell. So it can be denominated very simply in terms of a functionality that we call power. We think about nucleic acids, they're instrumental in the creation of DNA that creates a libraries of information in cells. So we could say it has something to do with knowledge. When we think about lipids, then lipids are basically create natural compartments in cells and allow work specialization, and therefore could be a carrier of a very simple function that we can call harmony. And proteins, similarly, we know, for instance, there are a large number of proteins, perhaps on some count, over 30,000 proteins in the human cell, different kinds of proteins. And so these are ubiquitously present across the cell and involved in all kinds of functionality. So we could just denominate it very simply in terms of some core functionality that I'm calling presence. Now, similarly, when we go back a level of granularity, so this is to the periodic table and the atoms that we know of, there are 108 known atoms, and these are basically categorized as S shell, D shell, P shell, and F shell. And we look at some characteristic atoms in each of these. I can make the case, for example, that similarly, if we look at S shell atoms, these are atoms like hydrogen and helium. We know that they are essential for nuclear fusion, power, basically stars across the galaxies, or rather in the universe. And so we can denominate in terms of some core functionality that we're calling power. If we look at P shell atoms, then here we have um, what I'd call is different archetypes that exist and are representative of different atoms across the periodic table. And then further, we have atoms like silicon and carbon that are used in computing machinery and life forms, respectively. So I could denominate that in terms of knowledge. We've got F shell atoms that are the largest atoms with a high atomic number. And so it's experiment in collectivity, so it can be denominated in terms of harmony. And then you've got D shell atoms that actually create all the infrastructure around us, the roads, the telecommunication networks, the cities, and so on. So I could denominate them in terms of similarly a core functionality of presence. Now, when we look at going back a level of granularity to the standard model, and here there's been work to suggest that all known quantum particles are categorized in four categories, essentially: Higgs boson, lepton, quarks, and bosons. And if we think about a surrogate for lepton, the electron, we know that the release or capture of it is usually accompanied by a lot of power. And so we could say that the lepton is, in terms of its core functionality, has something to do with power. Quarks, we know, determine basically are the components of protons, and protons determine the atomic number. Atomic number determines how an atom will behave in the universe. So we could say that the quark is a carrier of something that we're calling knowledge. Bosons, we know, are required for any other quantum particle to interact with other quantum particles. And so the core functionally has something to do with harmony. And then the Higgs boson, we know that any quantum particle that has mass would interact with the Higgs field via the Higgs boson. And so it has something to do with presence. Now, what we're saying here, basically, if we step back, is that there's a root pattern, presence, power, knowledge, harmony, that shows up in fractal form across these different layers of granularity. And this must therefore exist at the quantum layer from which all these other basically particles and more sophisticated structures ultimately arise. And so if we could build some kind of technology that was sensitive to these dimensions of present power, knowledge, harmony, it will likely give us some insight and some more sophisticated way to read what's happening at the quantum level. Now, I had introduced the idea of presence, power, knowledge, harmony, and here this is a depiction of what I'd call a fourfold quantum object code. And if we consider this orange sphere in the center to be where materialization occurs, and we have different forms of materialization as we just went through, quantum particles, atoms, molecules, molecular plans, and so on. These are all, as we suggested from the previous slide, are combinations or are determined by these four properties called presence, power, knowledge, harmony. Now, if we assume that presence, power, knowledge, harmony are implicit in the quantum level, which is basically depicted by this blue sphere, then the question is, how would these four innate properties show up to create all the diversity of this material reality? And we can actually engineer that through some simple mathematics. So we can first take the notion of a set, and here we can think about a set of presence, a set of power, a set of knowledge, a set of harmony that has, each set has a large number of elements that are related to the core element. And then we can have the notion, another mathematical construct of seeds, and each seed is a unique combination of elements from any of the four sets. And we can see that if we do that, then the seed becomes a unique identifier for any kind of surfacing of an object via the idea of being a quantum object in the material level. And so, for example, when we look at a protein, or we look at a lipid, or we look at the different atoms that we went over, each of these can be uniquely framed as an equation that relates to the elements in this presence, power, knowledge, and harmony. Now, what's more is that if we think about this quantum level as basically being the structure of space-time, energy, gravity, then what we can also say is that the granularity of space is determined by these subtle seeds that mathematically exist in the quantum level. And these seeds, as we saw, are unique. Everyone is unique. And so it sets up an archetype for knowledge. So what we're saying is that there's a correlation of this notion of knowledge with space. Similarly, whatever seed shows up materially in the subtle material aspect as a quantum object, it will display itself more concretely through time. And there's an implicitness of power there because regardless of obstacles, it shows itself as the seed it's intended to and as the matter it's intended to seed, if you will. So there's an implicit power of power, a property of power that's tied to this idea of time. Similarly, a subtle seed becomes more material through this transformation of energy, and that's related to this concept of presence. And we always know that the seed has a certain correlation with other seeds, and this is clear wherever we look materially. And so harmony has a correlation with gravity. And so, in other words, these four properties that we're saying exist in the quantum field, if you will, determine coordinates or aspects of code for any quantum object, and we can refer to this as space-time, energy, gravity. So any quantum object, in other words, will be accompanied by a fourfold quantum object code with the dimensions of space-time, energy, gravity. Now, that's instrumental to this idea of quaternary interpretation of quantum dynamics. And just summarizing what we've looked at so far, we considered the three levels when we first began with the reverse extrapolation of molecular plans, atoms, quantum particles, and we showed how they can be seen as being structured by a similar fourfold pattern. We looked at this idea of quantum object code and suggested that it's also basically has four components that we're calling energy, time, space, gravity that has a one-on-one correlation with presence, power, knowledge, harmony. We looked at in the quantum field the idea of presence, power, knowledge, harmony, mathematically being able to determine uniqueness at each of these different levels by considering it as sets and then as unique light seeds. And so what we're seeing if we step back is that there's kind of a cohesive quaternary dynamics that is basically reflective of the architectures and the possibilities that exist across any scale of granularity from the quantum level. And perhaps we consider all this orange here to be in the quantum level with different kinds of conceptual spaces. And then the material level, starting at the electromagnetic spectrum, bosons, quantum particles, atoms, and molecular plans. While we didn't go into detail in the electromagnetic spectrum and boson, I can make the case that these two are architected by a similar fourfold presence, power, knowledge, harmony set of dimensions. So when we step back and try to consider what is quaternary interpretation of quantum dynamics, because clearly we're looking at the quantum field, we're saying there's four properties that exist there that determine the different architectures of the layers that are rising subsequently from the quantum level. Then this gives us the idea that we're moving beyond probability, because if we look at existing quantum frameworks, they're basically driven largely by probability. And here, what I'm suggesting is that there's a dynamic that I call leverage, basically qualified determinism, because any kind of quantum object is not just probabilistically moved, but also there's this idea of a seed that is animating it. Further, there's a fractal order in quantum systems. And as I show, there's a quaternary fractal pattern that could be seen as a fundamental organizing principle that governs quantum dynamics across multiple scale. And I want to highlight this point here, quantum dynamics across multiple scale. So even if we're looking at the scale of the level of atoms or the level of molecules or molecular plans, there's a deep quantum dynamic that I'm suggesting is actually architecting how things are showing up. So, certainly when we're looking at quantum phenomena, then more manifestly we should be able to see and recognize these in these other layers where we've studied them in a lot more detail. So basically what we're doing is we're bridging quantum mechanics and reality. And by saying that quantum behavior is connected to the electromagnetic atom, biological systems, and so this gives rise to a more unified understanding of matter and life. And then highlighting again this idea of not uncertainty, but certainty. There's quantum certainty. There's an element of, or a dynamic of quantum certainty due to this quantum-based seeds that we're saying are at the core of any quantum object. And so if we consider these, then basically it gives rise to a new and very different quantum computing architecture that is not focused on what today's architectures are focused on, which is a completely different expression and a valid development of technology, and we're already seeing results of that. But here, what I'm pointing out due to QIQD is something that's untouched, that's virgin, that's different, that is showing us perhaps how we can play with the more creative elements that exist in the quantum field. Now, I want to just very briefly, I'm not going to go through all this, but here I've got essentially the comparison of a few different quantum mechanical frameworks, QIQD, which is the one that I've developed, then the Copenhagen interpretation, many worlds interpretation, Bohmian mechanics, and the Cubism framework. And I'll highlight a few things. So if we think about the foundational principle, then what we're saying in QIQD, it's basically qualified determinism via quaternary fractal patterns, and that organizes quantum dynamics across scale. If we think about the Copenhagen interpretation, then it's basically the foundational principle is that are probabilistic outcomes from wave function collapse that happen upon measurement, and uncertainty is fundamental here. When we think about many worlds interpretation, then all possible outcomes of a quantum event occur in branching parallel universes. And when we think about Bohm's approach, then deterministic evolution is guided by a pilot wave with hidden variables. And in Cubism, basically we have quantum states that reflect an agent's belief. Now, I'll consider a couple of different things. So if we look at the ontology, the nature of reality, then QIQD, as we went through, there's a multi-layered reality with fractal order linking quantum to macro scales. And this also implies, importantly, that quantum objects have meaning. So things are not random, they're not uncertain, they're not entirely probabilistic. There is, of course, probability that plays out, and that requires a deeper determination. I'll talk about that briefly in a few minutes. But there is implicit meaning in any quantum object, and the objective of QIQD based technology would be to leverage that meaning that already exists in any quantum object. If we think about Copenhagen interpretation and the nature of reality, there's no definite reality pre-measurement, and wave function is seen as a mathematical tool. Basically, in the many worlds interpretation, all branches of the wave function are equally real. We live in a certain branch. If we think about Bohmian mechanics, then particles have definite positions guided by a non-local pilot wave. And in Cubism, basically quantum states are not physical, only informational. If I look at implications for quantum computing, and perhaps that's the last thing that I'll consider here in the interest of time, is that QIQD enables qualified deterministic architectures. So there's a whole set of different QIQD gates that can be developed. There's different algorithms that would enhance coherence and predictability. In the Copenhagen interpretation, the implications for quantum computing are you've got probabilistic gate-based models and limited by decoherence. In the many worlds interpretation, all outcomes occur in separate worlds. So it suggests parallel computation across worlds, but obviously the practical implementation is unclear. If we think about Bohmian mechanics, then it's deterministic, but non-locality will complicate scalable computing. And if we think about cubism, it basically focuses on subjective probabilities, and there's implicitly less emphasis on hardware. We're going to move forward and look at the qubit comparison in here. We've got existing qubits that are, for example, like superconducting qubits, trap time, neutral atom, solid state spin, topological, discrete variable photonic, continuous variable photonic, and the QIQD qubit that I actually call a qubit, QIBIT for quaternary interpretation bit. And we've got some of the key players that employ these various kinds of qubits. I just want to focus on what the qubit will look like in the QIQD realm. So if we think about qubit setup, then basically it's a novel approach where the qubit is going to capture a four-dimensional state, so just as we had the fourfold code. And this we can think of as being represented by phase, amplitude, frequency, and polarization, and it would employ atom-light interactions to extract fourfold meaning. So that's in concept how we would extract meaning using these four mechanisms of phase, amplitude, frequency, and polarization. If you think about control and measurement, we would require advanced optical techniques to precisely control atom-light interactions, and then multidimensional measurement schemes for rich information. If we think about advantages, there's a potential for richer information content per qubit and a number of enhanced applications that I'll briefly mention as we go forward. One of the challenges would be complexity in encoding and decoding, and of course, experimental validation, which has to take place rigorously. Now, if I step back and just look at the last, say, 7, 8 years, there's been a lot of research work which I've been the sole author of in most cases, over 40 publications since 2017. There was a baseline 10-volume mathematical treatise on light where I basically asked the hypothetical question, what if light travels at different speeds? And that led to these 10 volumes. I then took core concepts that arose from this and framed them in terms of more concise technical articles. And these were peer reviewed between the years of 2020 and 2022, primarily in IEEE conferences. 2022 to 2025, I've written about 18 Forbes articles, and these are bounded to be 1,000 words, non-technical, but just to bring out core concepts of QIQD. 2024, 2025 has been a slate of peer-reviewed technical articles, both IEEE and Springer Nature, that go more deeply into QIQD. And then there's a new book that will be out in a few weeks by Springer Nature. It's pioneering new avenues in quantum technology. And it's basically, here's a snapshot of it. And it goes into a lot more detail. So it's based on QIQD, and it's based on essentially this idea of qualified determinism. So there's a new or a different mathematics that's proposed, different logic, different gate architectures, and a number of forward-looking applications. The object of manipulation here is energetic inference that essentially are set up so that matter can be programmed with these energetic imprints. And it suggested that these could result in transformative breakthroughs in quantum-based energy detection systems, room temperatures, superconductors, QIQD inspired nanodevices, and so on. Of course, there is a lot of work that would need to be done to get there. I also want to highlight another journey in a little more detail because it's been an instrumental or a journey that I've gone through with a lot of passion in the last 3 years. And this is my Forbes journey. I've acted as the Forbes Technology Council quantum computing community leader for 3 years. And I had mentioned 18 different articles. But if you go into these articles and also if you go into the events that I've led and hosted, I've color coded them by green and orange, where the orange are related to QIQD. So the view of quantum dynamics that I've developed, and then the green is existing technology. And there's essentially what I'm saying is that for the future, if you want to create killer apps, it has to combine these two sets of branches, the green and the orange. And that's going to drive the future of quantum AI, the future of quantum computing, and also the necessity for a multi-stratum approach to quantum computation. So to summarize, future vision is essentially that QIQD would revolutionize quantum science because it's suggesting moving beyond just probabilistic limits. We're also getting into a framework of qualified determinism. And in my perspective, that better aligns with nature's observed order. We're also setting up a new foundation, qualified determinism and fractal patterns. So there's a whole set of implications for quaternary fractal architecture. I mentioned a few of the different things that would need to be created. And there's also a mathematical redefinition. And there's different ways to interpret Heisenberg's uncertainty principle, Schrodinger's wave equation, even quantum superposition and entanglement, which all would imply a different stack of technology and software to make it real. As I said, there's now quantum mechanics is in this view, we're expanding quantum mechanics across multiple scale. So it's existing at the electromagnetic spectrum, at the scale of atoms and subatomic systems, macromolecular biology. And then further, there's simulation of quantum systems that would be done differently due to these different structures that are now supposed to exist in the fabric of reality. So moving from theory to technology, we've got QIQD-based quantum computing, and I go into this in a fair amount of detail in the pioneering new avenues of quantum technology. But we got to rethink quantum architecture. There's basically, as I said, there's now QIQD gates and logic. There's the equivalent of qubits, the qubits, and then there's generators of different energetic imprints, and then there's advanced QIQD algorithms that use qubits, generators, and the QIQD gates and logic for applications that we haven't considered so far. Some of these applications have to do with detection of quantum-based energy sources. So I'm suggesting that you could detect these fourfold energies regardless of scale of granularity. There's room temperature superconductors that we know are chemically very difficult to build, but there's a theoretical basis here because we're focused on energetic imprints of the difficult chemical elements that we're then combining into matter to then hypothetically create something that could conduct a superconductor at room temperature. There's QIQD nano devices. that would allow us to interact with the quantum level in a completely different way. And then there's also space-time and quantum integration, because specifically in the book, I end with a chapter on relooking at Einstein's field equations using QIQD, and that would unlock new pathways in applications for quantum gravity and even cosmology. So basically, QIQD I consider to be a paradigm shift in quantum thought. It's not just a new interpretation, but it's a fundamental shift in how we perceive quantum mechanics, computation, and their role in shaping future technology. So with that, let me wrap this up. Thank you.